Good afternoon to the most beautiful class there ever was. How are you guys? I hope you're having a great day. Now, let's get into the presentation. Today, we'll be presenting a brief yet very informative paper review on the matters of CO2 fertilization and carbon sink capacity. Brought to you by yours truly, Sahil, Lola, Sarah, and Nacho, in parentheses, Jose. Now, let's get into what CO2 fertilization is. CO2 fertilization is when the rate of photosynthesis in vegetation increases in the presence of greater CO2 concentrations. Because, as we know, CO2 is a necessary input for photosynthesis to occur. And because of human activity, there is a greater amount of CO2 in the atmosphere, higher levels of CO2 fertilization. Now, to summarize, more atmospheric CO2 means greater CO2 fertilization, and in turn, more, what do you think? Photosynthesis. Here, we have CO2 fertilization and carbon sink. To brush up, carbon sink is the capacity to absorb carbon from the atmosphere. And as you can see, this graph for a while, CO2 fertilization was leading to a decrease in atmospheric CO2 and therefore mitigating the climate change problem. This is because higher CO2 fertilization increases vegetation capacity for carbon sink. And, like we mentioned previously, plants are able to pull CO2 from the environment through photosynthesis and a related process known as intrinsic water use efficiency. And to better understand the relationship between CO2 fertilization and vegetation's carbon sink, let's look into the specific mechanisms of both photosynthesis and intrinsic water use efficiency. Now, we wonder and ask the question, how is photosynthesis a form of carbon sink? Well, we will tell you that. To answer your genius question, photosynthesis is a form of carbon sink because, as plants photosynthesize, they absorb CO2 from the atmosphere. Now, please note that a sink absorbs more carbon than it gives off. Never judge a book by its cover. Now, let's talk about the effects. Photosynthesis has been working as a carbon sink for a few reasons. Due to increased CO2, there is an increase in vegetation production. In this case, it is photosynthesis. This increase in photosynthesis is due to CO2 fertilization. When there is an increase in photosynthesis, there is more plant growth. Therefore, elevated CO2 levels increase plant growth. Now, let's get into some terms. There are a few terms we need to understand. First is the beta factor. The beta factor generally is used to characterize the plant response to increasing CO2 concentration. Scientists have found a robust decrease. This is due to the direct effect on foliar physiology and the indirect effects on lye. Now, what is lye, you may ask? Lye is the leaf area index, which is projected area of leaves over a unit of land. Now, we also need to know the gross primary production, GPP, which is the total amount of carbon compounds produced by photosynthesis of plants in an ecosystem in a given period of time. Studies have shown that there has been a change of GPP to CO2. Now we have the net primary production, NPP. This is the rate at which material is accumulated in excess of respiration. Enhanced growth primary production from the increasing atmospheric CO2 concentrations are leading to a larger net primary production and higher nutrient demands by plant. Now, let's move on to IWUE and CO2 fertilization. Now, moving on to another way increased CO2 fertilization relates to vegetation's carbon sink, we'll be talking about the intrinsic water use efficiency, which is the ratio of how much carbon dioxide is consumed per unit of water that is released during the process of photosynthesis. Research indicates that with higher levels of atmospheric CO2 concentrations, plants increase their intrinsic water use efficiency or take up more carbon per unit of water released. This results in a negative feedback loop for CO2, as the more that is present in the atmosphere, the more that it is taken in by the plants. While there is no definitive answer as to which mechanism is altered to assist plants in conducting this, a likely theory points to stomatoconductance as the answer. Now, we have to ask the question, why is it not working anymore? Data shows that this effect is actually decreasing. By changing nutrient availability and water soil, the negative feedback loop, vegetation taking CO2 out of the environment, is actually weakening. Now, let's talk about nutrient availability. Key foliar nutrients, such as nitrogen and phosphorus, are becoming limited due to higher nutrient demands from increasing vegetation production. Due to an increase in vegetation productivity to supply the world's needs, less key nutrients are found in the atmosphere and soil. There is a significant and spatially extensive decline in beta, which implies a substantial reduction of the positive effects of increasing atmospheric CO2 on terrestrial carbon uptake. Now, let's talk about water soil. When there is a low soil water supply, the nutrients in the soil become more concentrated, making the soil more nutritious. But consequently, when there is an excess in nitrogen fertilizer, the soil water decreases, and this could lead to a drought. Now, let's get into our conclusion. Overall, carbon sink is no longer an effective deterrent of climate change and its effects. But let's talk more about this. Through increased productivity of photosynthesis and in turn intrinsic water use efficiency, vegetation has been an effective carbon sink. However, studies over the past 50 years indicate that their ability to withdraw CO2 from the environment is decreasing because of the associated risk environmental factors of climate change. Thus, a very, very alarming picture is painted as one of the planet's primary defenses against global temperature increases are weakening. Now, what does this do? This only further emphasizes the need for a strong climate solution. And this also highlights the importance of systems thinking when it comes to climate change. Now, looking at CO2 fertilization from a single point of view, it may seem helpful, but to carry on, when all, and I mean all, the contributing factors are taken into consideration, a much, much, much different picture is painted. And sadly, this is not a picture that we want to be seen. Now, to recap what we just talked about, we talked about understanding CO2 fertilization, CO2 fertilization and carbon sink, photosynthesis, intrinsic water use efficiency, the problem that this causes, and the conclusion. Now, we hope you enjoyed and understood our presentation. Now, let's go out there and make this world and planet a better and healthier place. Thank you so much on our behalf for listening, and please enjoy the rest of your day and please protect our planet. Thank you again.